Okay, so before we get into the assumptions in depth, then let's cover that phantoms we missed doing yesterday. So if you would, turn on over to your page 5. We're going to re-look at that problem about Andre. I want to remind you, let's just go ahead and get into this problem, and then we'll go back to yesterday's results. So what was this problem about? We want to test the claim that the IRS makes that Andre makes more than $10 per tip on average. So they think he makes more than $10 per tip on average. Now, just based on our results from yesterday, when we had this, that his interval went from 1084 to 1386. What do you suspect we're going to be doing with this claim of $10? Okay, so the reason we do a greater than sign in the alternative is because they think it's more than. But what decision do you think we're going to make with the null hypothesis based on this interval being 1084 up to 1386? Probably going to reject it because this entire interval is what? Greater than $10. Okay, so let's run the test. So we need to confirm that by running a hypothesis test. And so the IRS claims that he makes more than $10 per tip on average. So let's start with so we're going to do our phantoms. Our P is not for parameter. Our P is not for proportion. Our P is for the parameter, which is what? Mu for the average tip for all. That's probably could be said better. Andre's tips. So the average per tip for all of his tips. Okay? And you need to make sure you understand this is what we're inferring about. All of his tips from our little itty bitty sample of 8. So let's then do, what is the H in the phantoms model? The hypothesis statements. Okay, so the null hypothesis would be in this case that what? So mu equals to 10. So we're going to start off saying, yeah, he makes $10 unless we have significant evidence that he does what they're wondering. And what are they wondering? Good. They want to wonder mu is greater than $10. Okay. Very good. So there's our pH. What is our A in the phantoms? That is our assumptions, and that's actually a separate lesson that we'll go into. So we're going to skip that. And now the N, the name of what we're doing. So what do you think the name of what we're doing is? Oh, one proportion. Stab me in the heart. Okay, thank you. Oh, and not 2. No, not 2 proportion. 1 mean. And then what? T-test. Thank you. Yes. Okay. So use that brain and don't fall into our habits of proportion that we've been doing for 6 weeks. Okay. So 1 mean T-test. That is 1 mean T-test. All right. Now, what is the T in our phantoms model? What does T in our phantoms model stand for? The test statistic. So you need to know this vocabulary word, what a test statistic is. We've been talking about it. What test statistic did we use for all of our proportion problems? Z. And then if we did a critical value, it was Z star. So Z. So let's review. When we would do a Z, a test statistic in our proportion problems, remember, not X minus the mean over the standard deviation, but we did P hat minus true P over the standard deviation of P hats, okay, which this right here was what? What was that standard deviation of P hats? It was another formula, which was our Good. Perfect. Okay, so that's what it was for proportions. So I want to parallel this to what we do for our test statistic for means. So here we go. What do you think the test statistic will be? Not a z-score, but a t-score. Correct. So t equals, all right, let's figure it out. What would be equivalent to a p hat but with means? X bar. Good job. Good. Minus, what would be equivalent to population P proportion with our means? The mu for our population mean. Okay, so it's the sample minus the population value. We're seeing how far away is our sample from that claimed population value. And then on the bottom, it needs to be the standard deviation, not of P hats, but the standard deviation of X bars. And here's something really important, guys. This is frequently what gets missed. A lot of times people, they get this proportion one is another formula. But again, when we're talking about samples and sampling distribution, this is another formula. It is not just, that is not the population standard deviation. Not the of course it's not, because we don't have it, or it's not the population, or just the S of X, the sample standard deviation. Do you remember what it was for sampling distributions? Good. It's going to be our sample standard deviation over the square root of n. So that's what's in the denominator. Our sample standard deviation over the square root of n. There you go. That's the last new thing when it comes to these. So let's do our test statistic. I'm going to go ahead and put our facts from yesterday. Remember yesterday that our X bar was 1235. Our sample size was 8. And our sample standard deviation was 225. So here we go. Do your test statistic T. X bar minus the mean. What's the mean I put here? That's 10. That's the claimed mean. We're seeing how far did the sample results I get. How far is the sample away from the mean? Over the standard deviation of the sampling distribution. So that's not just 225, but 225 over the square root of 8. Okay. Now, I believe when you do that math, it's 294. So think about that number. That's saying you're 2.94 standard deviations away from that claim of 10. So what is your initial thought about that in terms of, is it rare or not? What do you think? Is 2.94 rare? Is it? It's an outlier, right? Yeah. So if 10 is really where the data is centered, I got an outlier, and that's just pretty far out there. So now, so what do we do? See, we're saying if you say the data is centered around 10, I got this sucker way out here. So what do I need to do, though, in my next thing about testing this claim? I can't just say, oh, yeah, I got an outlier. What do I have to get instead? A p-value. O is obtain a p-value and compare it to alpha. So how am I going to get a p-value, this area out here, past 2.94? Oh, yes, I hear you. Norm CDF is the instinct, but it's TCDF. In fact, this morning when I went calculating it, I pulled it up and I almost put norm CDF, and then I got myself. Okay, so remember these are TCDFs from 2.94 to infinity, okay? But you must include the DF. Why do I have to include that DF? Good. Have to tell them what T curve to calculate on. So what is the DF here? 7. Okay. Now, at this point, let's make sure we have defined DF. That this right here, just writing this calculator speak, isn't good enough. You have to make sure that somewhere you have said the DF I am using is 7. You know, whether that's up here or at that point, but somewhere you have got to make sure you define that the degrees of freedom is 7. All right, so when I do that, I think I get 0.01085-ish or 6 or something. I don't know, somewhere. So let's go point. So somebody check me on that because I just kind of did that and yay. Okay, cool. So I did that earlier this morning and I was checking it from memory. So there is my p-value. So p-value equals 0.011. Okay, 2 significant digits, 0.011. And how does that compare to alpha? It is less than our alpha of 0.05. So that's our obtain a p-value and compare it to alpha. So what is our M of the phantoms model? Make a decision. And what would our decision based on that p-value is? Low. Yep, reject HO. Okay, reject HO. There we go. And so now our conclusion. So we say, since 0.011 is less than 0.05, I reject HO. Okay, and now I'm going to stop for a minute and let you get caught up. So the evidence is telling me to reject HO. Therefore, what am I saying about HA? I have evidence that the average of all of Andre's tips is greater than $10. Okay, so that final statement, I have evidence to suggest or support or whatever that the average of all Andre's tips is greater than, I probably should write that out. Greater than, sorry. That's not, greater than $10. So what's the IRS going to do to old Andre? Yep, file him for tax fraud and make him suffer the consequences. Now, question. Does this conclusion jive with what we thought was going to happen based on our interval right here? Yes, it does. Since our entire interval was at $10, we from the get-go kind of were anticipating that we were probably going to be rejecting the null hypothesis, okay? So very good. So that is how you complete a phantoms. And so now we're going to go into the assumptions. So let's get into that. Let's see here.